question is, show that if the normal process is y-sense stationary, then it is a strict sense stationary. So since xt is a, let's say xt is a y-sense stationary, so the time shift didn't influence the density function. So we can write down the density function fx x1 to xn, and given a time at t1 to tn, and we make a shift epsilon, so fx equal to x1 x2 xn, t1 plus epsilon, t2 plus epsilon, tn plus epsilon. We make a shift epsilon on the time, and we can write down the density function this way. So the 1 over 2 pi the n roots of delta c times e to power negative 1 over 2 x minus 2 the transport of this, and the inverse of c times x minus 1. So when we try to calculate the c, so c is equal to the expected value of x minus the eta times x minus eta's transport. So that we can calculate it like this way: the expected value of the xt1 minus expected value xt1, and to xtn minus expected value xtn times xt1 minus expected value xt1, the same thing here. Let's just transport. So after calculating, we can see here, when we multiply them, we got the expected value xt1 times xt1, and then minus the 2 eta xt1 plus eta square, which we can rewrite this part to rt1 t1 minus eta square. And we can, after we do all the calculation, we can see it's this one, and yeah. So since t1 and the tn is equal to each other, we can rewrite it, and we can see the diagonals here. We can rewrite them to r0 minus eta square. So which we can rewrite the statement to the c t1 minus t2 t1 minus t3 tn minus 1 minus tn equal to c t1 minus tj when I is not equal to j. So we can see that the density function fx x1 x2 xn t1 t2 tn given the time, the fx x1 is equal to the fx x1 x2 xn ti minus tj when the I is not equal to j. The same thing for the when we time shifted this time shift epsilon time, we shift the epsilon time on the t, so we got the fx x1 x2 to xn given the t1 t plus epsilon t2 plus epsilon, and we can use the formula here. Looks like this one. So the epsilon cancel. It will equal to the function here, which we can see like for this one, since it's normal distribution, and we can see it's equal to this, which proves it's a strict sense stationary.